This video is on iterative improvement. So we have been focusing on different designing techniques of algorithm. So this iterative improvement is an improvement technique where we have a feasible solution. That is, we have solution for the problem, but we are going to get the best solution. The best solution is going to be the optimal solution. Let us first look into this problem, which is called as the linear programming problem, commonly known as LPP problem. So just before getting into the problem or an example, this is the normal way of representing. We either have a maximization or a minimization, which has to be solved with c1 x1 plus, and we have till any number of variables subject to some equation with some expression, and everything have to be a non-negative variable. Okay, let's quickly move on to the example. So this is going to be a problem. So discussing about the problem, we have a farmer, and this farmer has 320 acre farm on which she plants two crops, corn and rice. For each acre corn planted, her expenses are $50, and for each acre rice planted, her expenses are $100. Each acre of corn require 100 bushels of storage and yields a profit of $60. Each acre of rice require 40 bushels of storage and yields a profit of $90. If total amount of storage space available is 19,200 bushels and farmer has only 20,000 on hand, what would be the maximum profit or the yield? This is the question. To understand further, the farmer has 320 acres. So let's have it as 100, 100, 100 and 20. Okay, so all she is going to plant are corn and rice. So corn plus rice, it should be less than or equal to 320. Okay, so now this is the problem which we have to look into. So corn expense. So expense for planting corn is going to be $50, and for planting rice it's going to be $100. And storage available for per acre of corn is going to be 100, whereas the profit which is going to be yielded is going to be $60. Whereas the case of rice, the storage required is $40 bushels, and the profit is going to be $90. Okay, so this is how we go about by the statement, and the amount of space available for storage is maximum 19,200, and the expense, that is the farmer has only $20,000. So beyond this the farmer cannot go. Now let us quickly write the statement in terms of maximization or minimization. So from the statement we understand that since it is a profit, we are going to have a maximization problem. So this maximization problem, which profit will give me, like how will I get the maximum profit is, this is the profit, and I represent C for corn and R for rice. So maximum is 60C plus 90R. So this is how I arrive at this particular factor, which is called as the maximization factor. So it is subject to my availability. So here the part which I have to write as of this is $50 for corn plus $100 for rice. So the amount is going to be 20,000. So this means that my maximum can be only this. And afterwards, this 100 storage of corn plus 40 storage of R, and the maximum space available is 19,200. So I come out with my statement as of this, and making use of all these variables, I have to go about by solving the problem. So let us first look into the normal conventional method of solving the problem, then the graphical method, then we'll move on to the simplex method. So this is the statement. So we have let's take it as 50C plus 100R is going to be less than or equal to, and the next one 100C plus 40R less than or equal to 19,200. So now let's equate it. We can have the substitution method, and we have the answer as substituting the value of R So we have C equal to 140 and R equal to 130. So for yielding the maximum profit, it is 60 into 140 and 90 into 130, which is going to give 20,100. So this is one way that we can have the maximum profit as 20,100. Knowing that C is 140 and R is 130, and the maximum profit what we get is 20,100. This is using the conventional substitution method. Now let us look into the graphical method in solving the problem. So it is for the first equation and the second equation, where we put C is equal to 0, R is equal to 0, C is equal to 0 and R is equal to 0. So on deriving at that particular, R is equal to, so C comma R is 0 comma 200. So when R is equal to 0, so that is 400 comma 0. So in the case of the second equation, when C is equal to 0, when r is equal to 0. Okay, so when we plot it for equation 1, when c is, we'll have this x-axis as c and y-axis as r. When c is 0, r is 200, this portion, and when c is 400 and r is 0. This is how we go about plotting for this is equation 1. So c is 0, r is 480, and this is 192. So the point of intersection is this. So this is the area in which we get the solution. So this point is C140, comma, that is the place where we get the maximum profit. So this is the graphical way of solving the problem. And these profits can be calculated by substituting in our formula. Where here it is going to be R and here it is going to be C, and for this it is going to give a maximum of 20,100, whereas for this it is going to be 18,000. For this it would be so with this we might have different range of profits, but the other factors do affect because of storage space and the amount of like money available. So this is the feasible solution for graphical method. So now we are moving on to the simplex method. This is under this iterative improvement. So this is going to work under iteration. One iteration after the another, it is going to take place and there is going to be improvement in the solution. Now these are the conventional and the graphical method which we have already dealt with. Now let's look into how this simplex method is going to be solved. Okay, so now let us rewrite all these things in order to make it feasible. So then profit now, which is there, 60C plus 90R, it's going to be the profit which can be rewritten as minus 60C minus 90R plus P, that is equal to 0. Okay, so similarly, like we will have this first equation, 50C plus 100R plus a constant S1 equal to 20,000. The second one, 100C plus 40R plus a constant S2 equal to 19,200. Okay, so having all these variables, let us formulate the table structure. The table, let us initialize it. So these are the different steps as such which we are going to look into. Initialization. So how to construct the table? We have corn, C, we have R, rice, we have S1 as one constant, S2 as another constant, we have P, profit, another constant, and a solution. Okay, so all these have to be included. So taking the first equation, 50 for C, 100 for R, and S1 we have 1, S2 we do not have, profit P we do not have, and solution is going to be 20,000. Similarly, from equation 2, 100 for C, 40 for R, we don't have S1, so 0, S2 is 1, we don't have P profit, 0, and the solution is 19,200. And we have this profit equation, so minus 60C, minus 90R, no S1, no S2, 1 profit, and no solution. So this is our table structure. Okay, so now the next step is going to be the optimality test. So let us test the optimality test. So how are we going to test is find out the pivote element using this column, which is the minimum of all. The lesser value is going to be minus 90. So this is the minimum in this particular row. And we are going to consider these elements. So among these, how are we going to select is this solution, the value in this divided by the number in this column. So 20,000 divided by 100 and 19,200 divided by 40. So we have values of 200 and 480. So still further selection between these two, which is the minimum? This value is the minimum. So in this we take 100 as our pivote element. So operation with respect to this has to take place. That is, entering element is going to be R, and we are going to eliminate S2 so that we get the new solution. Okay, so how are we going to eliminate this? The next column which we are going to formulate should contain the value 1, 0, 0. So how are we going to get this 1, 0, 0? That is, the entering element has to be 1. All the other elements in that particular column have to be 0. So with respect to R1, so we have this as R1, R2 and R3. So here R1 is going to be equal to R1 divided by 100. Okay, so 100 divided by 100 is going to give us 1. So this will become 1 by 2 and this 1, and this is going to become 1 by 100, 0, 0, 200. Okay. So now what substitution can we make with respect to R1 to R2 and R3? So we want this 40 to become 0. So R2 is going to be equal to R2 minus 40 R1, and R3 is going to be 90. We want this 90 to become 0. So R3 plus 90 R1. So substituting these values, we have 80 minus 2 by 5, 1, 0, 11,200. Whereas in this case, we have minus 15, 0, 9 by 10, 0, 1, 18,000. This is at the end of the first iteration. So now this is our new profit which is generated at the end of first iteration. So now first iteration is over, but still we have not got the solution. We have got a solution as the feasible solution as 18,500. But this is not the best solution. So let us repeat the same iteration again. So the leaving element and all those things we have to find out. Now again the optimality test, which is the minimum of these. It is going to be minus 15. So the row which is going to be influenced is this row. So how are we going to change it? This solution divided by this value. This solution divided by this value. So what we have here is the minimum has to be taken. So since this is the minimum, we have the test which has to be performed is going to take place to this particular element. So what is the ultimate inference which we have to arrive at is this element should become 1 and the rest should become 0. So the operation which takes place at R2 is going to be R2 divided by 80. So the answers would be so now to change this 1 by 2 to R0, R1 should be transformed to for converting this 15 into 0, R3 has to be transformed by adding this. as an end result, we will be having and here the element which has gone out is going to be S1. So the profit which we have arrived is 20,100 with C value, with R value as 130 and value for C as 140. So that is been the answer throughout, and the solution also implies the same. So now one more thing. So here this particular problem we have seen in terms of maximization. How do we go about by finding in terms of minimization? So we call this concept as primal to dual. So what are the factors which are going to be kept into consideration are this 20,000 and 19,200 are the factors which are going to influence. So what we do is we have to have the minimizing factor as 20,000 y1 plus 19,200 y2. So this is going to subject to, so all the factors which come under con will be considered as y1, that is 50 y1 plus 100 y2. So this is with these two, and the profit is going to be this. So it cannot be more than 60. Whereas to the other statement, it is 100 y1 plus 40 y2, where for rice the maximum is 90. And the condition here is y1 comma y2 should be more than equal to 0. So this is our simplex method. Iteratively improvement has taken place. So here this is the linear programming problem, LPP. We have solved it using the conventional method, graphical method, and the simplex method. In simplex method, we have tabulated, we have found out the pivot element, and we know now how to substitute by the normal substitutional method, and we have got the solution with the respective answers. And this is how we convert our maximization problem into this minimization dual statement. So hope you enjoy watching it and you have learned. See you in our next video. You may subscribe and like our video for further updation. Thank you.